want to mention that tonight is being hosted by Alchemist Cafe and the Irish Science and Technology Journalists Association, so many thanks. So let me introduce the panel. What I'm going to do is introduce everybody, and then each person can give a little bit of a talk about what they'll be talking about tomorrow, and then we can kind of get stuck in with the questions, if that's okay. First of all, let me introduce Lona Frank, who is a Danish journalist. She has a PhD in neurobiology and a background in research. She's a staff writer at Denmark's leading newspaper, Viken Davison, I say in my best Danish accent. And she is a contributor to the likes of Science, Nature, Biotechnology and Music. She's also a prolific author. I'm actually reading one of her books at the moment called My Beautiful Genome. That recently had the accolade of being listed as one of the Royal Society's Winton Prize for Science books. Lona is going to be talking about how neuroscience and genetics are current revolutions that we are living through. And she'll be talking about what they mean for our understanding of what it is to be human.
As you said, I'm a science journalist. I used to be a scientist. But what always really interested me about science, and certainly as a writer, is not so much the particular field or what is actually coming out of science. You know, what are they doing with cancer right now? What are they doing with fruit flies or whatever? What I think is really interesting about science is what it does to our mentality, what it does to our society, what it does to the way we think about the world and ourselves. And so tomorrow we're going to have this panel discussion. We're going to be 4 different people who are writing and thinking about what science and technology really means for who we are as people, how we look at being human. I think when you talk about scientific revolutions, we usually think about, Copernicus and Darwin and these big figures and something that happened a long time ago. Now science is sort of everyday and it's everywhere and it's going on all over. But we are really living through, I think, a couple of scientific revolutions that will change the way that we look at ourselves. And neuroscience, I could use as an example here, because what neuroscience is really doing now that we can look into the living, thinking, feeling brain, is that it is changing everything we used to think about the self. And things like soul and spirit, for example, are simply disappearing. Because what we are realizing with what is coming out of brain science, when we're looking at human nature through brain scans and so on, what is going on when we feel love for somebody, what is going on in there when we think about something, so on and so forth. What's happening is that we are anchoring everything human in those 3 pounds of wet stuff between our ears. The realization that we are our brains also tells us something that is kind of new, that we don't have an essential self. I mean, we used to be sort of on the lookout for, who is the real me? I have to go and find myself, find out who I really am. But if we are our brains, and that is what is emerging, then we are our immediate brain state. So if our brain state changes, well, we are a different person. We used to think about ourselves as, a self. It wasn't a brain. Each of us was a self, a soul. Now we are a brain. That's always changing. And I think that will turn out to be one of the big revolutions when we, 100 years from now, look back on how we used to look at, who is a person and how we now look at it. So I think I'll stop there.
Great, thank you, Lona. Very interesting. Yeah, absolutely. In fact, I was at a masterclass with Peter Doherty today, who is sorry to name drop now, but he's a Nobel Prize winner, and he was making some very interesting comments about how science and technology often change with respect to each other. And I think we're getting to the stage of having the technology now to look at the neuroscience, and that's changing our perspective. Come on in. Sorry. Thanks. Our next panel member is Michele Garfinkel. She is the she's the manager of the EMBO Science Policy Programme, EMBO being the European Molecular Biology Organisation in Heidelberg. She was also until last year a policy analyst at the J. Craig Venter Institute, and Craig Venter will be at ESOF. Tomorrow he's going to be giving a speech on what is life, to recapitulate the Schrödinger speech of 1943 in Trinity, and he'll also be doing a plenary. She's now at EMBO, and she has a background in microbiology, studied microbiology at the University of Washington in Seattle, and has a very strong interest in science, technology, and public policy. Tomorrow, she's going to be moderating a discussion on policy issues in performance enhancement with drugs, which I think, given that the other big event in the world coming up, apart from ESOF, is the Olympics. So that's definitely something that's very newsworthy. Michelle, would you like to tell us a little bit about what's going to be happening tomorrow in that discussion?
No, I spent a lot of time in Washington, D.C., so I always have to have the little security blanket paper, but I'll try to make eye contact. So what we're trying to do with this session is really focus on what I think is really the issue of science informing policy and policy informing science. So the Friday Policy Day here, you will see a lot of that. In my reading of it, it's a little biased toward how should science influence policy. There's a backwash from that that's very important. And I think that this session talking about basically performance enhancement of human athletes is something that we really can use. Even if you're not interested in that particular topic, I think it's a really excellent model for a lot of issues. Even as Lona just described, this issue of what is a human, and is there a line you could cross where enhancements that you've brought to yourself no longer make you human? And this is part of the spectrum of issues that people are concerned about. So I think that one of the things that comes up in the issue of performance enhancement is the fairness of it. And when you're talking about issues of fairness, you get into issues of emotion. There's a lot of opinion and a lot of emotion around this. And one of the things we try to do in the policy program is use techniques through a type of policy analysis called technology assessment, where we can step back a little bit and ask what really are the issues here, what do people agree on, and what do decision makers need to know. So for performance enhancement right now, there's a general sense that this is bad, right? And you can do this by observation. There are lots of agencies that do nothing but keep an eye on athletes to make sure they're not cheating. But could it be that it's not bad? So at our session, in addition to Werner Franke, who may be here or not, who is a biologist and an athlete, who will be talking about why it is a problem for performance enhancement to be happening in a widespread way or even in a particular way. We will also have Julian Savulescu, who is an ethicist and a philosopher, who has argued basically that from a utilitarian perspective, the policing of this is impossible. It is inevitable that people will try to enhance themselves. There's also a virtue ethics perspective. This is not necessarily against the spirit of sport. And that's a really interesting question, right? What really makes an athlete, what makes a sport fair? You can think of several ways to go about this analysis. So one of the analyses that I like to run, and others came up with this one first, but to think about if it's really a concern for you that somebody has enhanced themselves in some way, how about if we have all sporting events in parallel? So one track will be people who are clean, using that terminology, tested, maybe we put them in a bubble somewhere for a month before the event so we know they haven't used drugs. And another track will be do whatever you want and let people run side by side that way and see what happens. Now, this is not going to happen, but as an analytic tool, it's actually quite useful to push back on what is it that you object to. So I think in this session, we want to try not only to sort of produce these facts, but also think about how the pros and the cons and the philosophy and the biology really intersect together. And I think I'll leave it at that and leave the nuance for tomorrow.
Do you think that we've gone a little far in that? Have we become reductionist? I mean, people talk about now the neuroscience of falling in love, the neuroscience of listening to. Has it become like the gene for? Has it become too easy to to make those leaps into what's happening in our brain?
I think, in fact, if you look at brain science, and if you don't just look at the articles in the newspapers about brain science, because they are usually very reductionist, and the same thing when we're talking about genetics. But if you ask brain scientists, they will tell you that their methods are really rough. I mean, it is a leap to go from, oh, we see a nice red spot here on the image of the brain, to what exactly is going on in there. You can tie different functions to different areas and activity, but what is exactly going on in those millions of cells, and how are they communicating? Our scanners are just too blunt instruments right now. So I think there's a long way to go before you can say too reductionist, if you can even say too reductionist. I think in fact you have to look at it as you can understand a human being, or say a brain, on different levels. You can reduce it to, the chemical compounds that are, reacting with each other, the proteins, the cells that communicate.
Actually, I think the microbes that live in our gut are actually now running the show, aren't they? That's the latest thinking.
In some people I have that impression, yeah. No, but sure, we are sort of a superorganism, you could call it that. And you can look at, the human organism on different levels, and you can understand it on different levels, and you could also understand a human at an anthropological level.
Sure.
So it's just a matter of you have different levels of understanding, and they all in some way come together. But it's like that Bohr experiment. In fact, Niels Bohr. You can't look at all levels at the same time.
Yeah. Great. Thank you very much. Our next guest is Alaa Ibrahim, who's a physicist at American University Cairo and has a distinguished career as a space astrophysicist. He studied quite a bit in the United States and moved back then to Egypt. He made the discovery of a new class of cosmic objects. Now, pardon me, I'm not an astrophysicist. A new class of cosmic objects known as transient magnetars that possess the highest magnetic field in the universe. Tomorrow, he's very busy tomorrow because he's going to be talking in 2 sessions. One will be on peer review, meeting the challenges, and the other one is a very interesting question that I think gets really the heart of what scientists do and what they find out. And scientists say, but how do they know? It struck me that when I was a kid in school, you read all the stuff in the textbooks, and it always struck me, yeah, but how do they know that? And I think that's really going to cut to the heart of a lot of what goes on in science.
A question for Alaa Ibrahim. You showed us the classical, powerful example of an experiment done by Galileo Galilei. And of course, it's very visual, very good for communicating how science works and how you use the scientific method. But today, science is far more difficult. Many issues are quite complex with many different paradigms to accommodate into the same model, because often scientists discuss models of the processes, and it's difficult to formulate this clearly, and is thus this scientific method losing its clarity and the opportunity to communicate it. What's your opinion on it?
I agree with what you said, but I disagree at the point that science is going to be difficult and complicated, because nature is actually beautiful and simple. So when we have the right idea about nature, as Einstein said, the answer has to be simple and has to be elegant and has to be beautiful. So we have a degree of complexity in certain fields of science. If you are referring to particle physics, if you are referring to life science, the human genome project, and so on. Yes, so to make a new discovery, you have to be using a new tool. You need to build something like the LHC or the CERN, so that you can discover the Higgs boson. But there can be great breakthroughs with new technology, because what Galileo used is the new technology of his time. He was among the first to use the telescope. The telescope was just a new invention of his time. So he used that to look at the cosmos, and he discovered an array of new phenomena, the moons of Jupiter, the craters on the moon, the sun spots, and the idea that the sun rotates. So I think we do need new technology so that we can make breakthroughs, but the scientific method is actually at the heart of what we do. We still have to do the observation, whether they are with our eyes or with the new tools of our time, and we used to come up with a hypothesis and we have to retest them. So in a way, we need to have and to put the new technology in the investigation of the natural world, and we need to get this accessible to people. There is a huge amount of data accessible to lay people, and this is what we call citizen science. There are high school kids in the US and also in Europe. They are discovering new stars. They are discovering new phenomena. Once you know how to search, once you know how to make use of the data, so there are a lot of resources, and you have to have the right mindset so that you can pursue or you can make use of those data and those resources. So in a way, you have to really build your tools of how you go about to investigate a new phenomena, but the scientific method is at the heart of all this, and the approach has been the same. I agree it is getting more difficult because we have an array of observations that you need to use certain tools to make meaningful use of them. There was one thing I'd like to add to what I to the intro part that I gave is the scientific method and scientific thinking has been used in other areas as well. The book about men are from Mars, women are from Venus by John Gray, in a way they are adapting that approach as well.
Thank you. Has anybody else got any questions? Here.
Just following up again on the scientific method. Now, one of the key aspects, as I understand it, is falsifiability. Now, that itself evolved on from replicability in an earlier theory, and I was wondering, is that theory still evolving, or have we decided now that the scientific method is it for all time? Because as I see it, there are some, well, not problems, but take the Higgs. The way to falsify that is for someone else to have a Large Hadron Collider and run the data, which doesn't seem all that likely.
Right. They are
Sorry, everybody got the question there? The microphone? Okay, all right. So do we need scientific method 2.0 or Large Hadron Collider 2.0?
Right. Any scientific knowledge, any scientific information, theory, model, they have to be falsifiable. You should be able to prove them wrong. So if somebody would tell you, this is my theory, but they will tell you, there is no way for you to prove it wrong, because you need a huge amount of energy, or you have to wait for 200,000 years. Then this is not a scientific theory. A scientific theory should be able, you should be able to prove it wrong with the present means. So in that regard, the standard model that predicted the Higgs boson, they actually predicted at a particular mass, at a particular energy, under a particular reaction. So in a way, they give us the recipe to prove them wrong. So what we do is we build the experiment, we build the LHC in CERN according to their prediction. They give us the guide, they give us the map, they give us the recipe, and it did happen. What we are waiting is another dimension of the scientific method, which is it has to be repeatable, it has to be reproducible, it has to be testable. So other groups, they should be able to come up with the same discovery under the same conditions. So this is a dimension altogether, to be repeatable, to be testable, to be quantitative. But the other one is the ability, as you would put it, to be falsifiable. You should be able to prove them wrong. If somebody is making up a hypothesis, a new theory about any phenomenon, you should be able to go and tell them, how can I prove you wrong? Any scientific theory must have that component in it.
I think, Lona, you want to come in there?
Yeah, I just have a question. Doesn't that mean a problem for string theory?
Indeed. But in a way, the string theory is saying that you need to have a huge amount of energy that might not be present on Earth now. But luckily, we have the cosmos.
Right.
So the energy in the cosmos are way, way, way larger than we can produce on Earth. So what we need to do is we need to build better telescopes so that we can really harness the information out there, and we can tap on huge amount of energy that there is no way for us to actually build. So string theory is still a scientific theory because they publish, they use peer review. They are offering a recipe, they are offering a way for us to prove them wrong. Our inability due to the limitation in the technology is going to be changing soon with new optics and so on. It is no different than the prediction that really made Albert Einstein the most famous scientist of all times. It was not his equation E equals mc squared. It was his prediction of the bending of light that happened after after the 1919 total solar eclipse. And what he said is gravity can bend light. Gravity can bend light, but you need a mass like the mass of the sun. There is no way on Earth that you can bring a body and shine a beam of light and you measure the bending. You have to use the sun, and you have to wait for the moon to come between Earth and the sun so that you can see the bending. And it did happen, and this is how, he was a rock star after the 1919 total solar eclipse. So it was a far-fetched, or it was a prediction. Many people said there is no way for us to prove it. But when you tap on the cosmos, there are always answers.
You were in Cairo, I think, during the Arab Spring, and there's a definite shift in Cairo towards the more religious persuasion. Do you think that will have an impact on science and how it's practiced in Egypt?
We are hoping that the new Egyptian president and the government to come, we hope that they will follow the Turkish model. And we see that it is actually part of being scientist, is to actually engage and to inform our elected officials of the role of science in developing Egypt and the right of the scientist to academic freedom to pursue the lines of research that they see fit. So Egypt at a juncture in time and history, and we are hoping for the best. We have put a system now that I think in due time will produce the leadership that is going to take Egypt to the class of the world of the developed nations. And I am really optimistic that the current president and the next government will look at Turkey as a role model, and even maybe better. Maybe they will invent something new. But we have no issues right now. We are still very early, but we haven't seen any evidence that would really, because as I pointed out, we are evidence-based. We put emotions aside, and we will work hard to really maintain our academic freedom, the pursuit of knowledge that should be available to all. And I think the best thing is we now have the system that is going to produce another president in 4 years. So this is in a way the democratic system that it's analog to the scientific method. That people are going to see how the president and the new government are going to perform, and we are gonna vote again in 4 years. Yeah.
How are we going to be able to integrate all of these views that I know are in this room, I can hear them, and how we turn that both into good policy and into good science?
Among the greatest discoveries in science over the past 10 years or so is the discovery of extrasolar planets. And as I pointed out, there are more than 600 other planets outside our solar system. And I would really be interested in learning when are we going to discover the Earth's twin, because we are looking now among these 600 to which ones is very similar to planet Earth, so that it might actually harbor life as we know it. And the key is it has to lie in what is called the habitable zone, the safe distance from its star, so that water would exist in liquid phase. It is not too hot, or water would be vapor. It is not too far, or water would be ice. So I think that would be, I think, the greatest discovery to find a habitable planet and possibly life beyond Earth. This is going to shift everything on Earth. And I actually hope that it will happen in our lifetime, so that we can see it as most of us have witnessed or have seen, landing on the moon, setting a foot beyond Earth. I think it would be really great to see life happening beyond Earth, outside the solar system. That would be the greatest discovery of all time, because there is a belief in the scientific community that mankind is destined to be multi-planet species. It is likely to happen in another 1,000 years that we are going to have Earth and have another planet that we can travel to. So finding extrasolar planets is really key. It is not a luxury science. Taxpayers should be proud that their money is being put in such research. We should have another home in 1,000 years for our kids.
Holiday home in the cosmos, lovely. Lona, how about you?
Yeah, I think a really interesting thing that could happen, I don't know, in the next probably 10, 20 years is the creation of artificial life, truly artificial life. I mean, Craig Venter rebooted the first cell, and that was nice. But to take totally inanimate molecules and put together something that's alive in the way that it's it's metabolizing, it's reproducing, and it's evolving, and it's completely man-made. I think that would be really interesting and a shock to the system in many ways.
Great, thank you. Now, I think I'm told there's food at the back and it's starting to go cold. So, Ankesh Sternok, the last question, I think is down here. No pressure now.
It's a short one. Go back to my beautiful genome. I have 3 amazing children with 3 amazingly different personalities. How close are we to discovering why?
Are you sure they're yours? I think it's still a ways off that you can really, say from a genome, this person is going to be like this if you put him or her in these circumstances, and so on and so forth. But I think it is doable. It is a question of understanding more about whole genomes, and that's going to come over the next, many, many years when we really have many whole genomes and compare them sort of over time. So what happens when people actually grow up? And we look into how the brain develops from that genome or that genome or that genome. I think it's going to happen. A really good understanding of why we are the way we are will come about in 15 years, I think.
Okay, great, thank you. Well, thanks to all of our panellists tonight. I think it's been an extremely stimulating discussion, and I'm glad to have had this kind of sneaky taster of what's going on tomorrow in ESOF. Before we wrap up, I would like to give them each a little present. As I said at the beginning, I'm not Mary Mulvihill, but she did write this book called Ingenious Ireland. And I want to give each of our panellists a signed copy. I'm just thinking, I hope none of you are flying Ryanair. This is pretty heavy. And this is a book that tells you a lot about, it's actually a really good read. It tells you a lot about the history of science in Ireland, and you learn plenty from it. So thank you very much, panellists.
Thanks a million, Claire, and thank you all very much for coming along this evening. And thanks so much to Lona, Michelle, and Alaa. Really enjoyed that. So I'm Judith from the Alchemist Cafe, and just to let everybody know, this is the first of 3 events. So we have a similar event tomorrow evening, kick off at 6:45, and Brian Trench, who's over here, is going to chair this event for us.